Alright, for number 11, you've got to solve for x. And so what I did is, and I underlined it in the same color to so you guys can match it up. So this term right here, I use the double angle formula or multiple angle formula to rewrite it as this. And once you do that, because as it is in its original state, you can't do anything with it. You can't factor anything out because this angle and this angle are different, so they're not the same term, so you can't factor anything out. But now that you have it in this form, you have a sign in common. So that's what I did here. I took out a sign, I factored it out, and this is what the remaining factor. So then you set each one equal to 0, and now it's like the equations from the previous lesson. So sine x is 0 at 0 and pi, for x 0 and x equals pi. And then cosine x equals 1/2 means that x is pi over 3 and 5 pi over 3. Now 13, we're actually going backwards. You have 4 sine x cosine x. Well, that's not any formula with the 4 there. But I could factor the 4 into 2 times 2. And once you do that, once you make that into a, you should be able to recognize this as one of the formulas, which is sine 2x. And so now I'm solving it like a multiple angle formula. So I'm dividing by 2 and I get this equation right here. And because that's a 2x, the domain goes from 0 to 4 pi, not 0 to 2 pi, which means you're going to go around twice around the circle. So 2x is the angle that is associated with 1/2 for sine is pi over 6 and 5 pi over 6. And you're going to go around another time, so remember you double the denominator and add it to the numerator. So that gives you 13/6 and 17/6 pi. And you're solving for x, not 2x. So all of the 6's here get multiplied by 2 because you're multiplying by 1/2. And so this is the final answer right here. Number 15, again I color-coded it. So here cosine 2x is equal to 2 cosine squared x minus 1. Now I had 3 choices for that one. Why did I choose this one instead of the other two? Because this is the only one that only has cosines as a trig function. And because it's a cosine, that's why I chose that one. Okay, so that's what it is. I brought this down, I brought this down. I wrote it in standard form right here. Then I factored the quadratic right here. Then I set each factor equal to 0. And then I isolated the function here and here. And so for cosine x equals negative 1/2, that would be at 2 pi over 3 and 4 pi over 3. Cosine x equals 1, that only happens at 0. Number 17, you've got sine 4x equals negative 2 sine 2x. Now here the angles aren't equal to each other, so I cannot combine them. But what I could do is, again, factor this 4 into a 2 times 2. And now I have a sine 2a. Here my a is 2x. So I'm going to use the formula of sine 2a. So here it is, 2 sine 2x cosine 2x. Remember the a is 2x. And then I bring this term over to the left side, so it becomes plus 2 sine 2x equals 0. Now I have a common factor, 2 sine 2x, and it's right here. When you factor that out of both terms, this is what the remaining factor ends up looking like. Because I took out 2 sine x from here, 2 sine 2x from here, and 2 sine 2x from here, so you're left with this. So you set each factor equal to 0. That's what you have right there. When you divide by 2 on both sides, you still get a 0. And then here I subtracted a 1, and I got this. And remember, this is 2 times around the circle because it's a 2x, so the domain is from 0 to 4 pi. So 2x, the angle associated with the ratio of 0 for sine is 0 and pi, and then you're going to go around another time, so you're going to add a pi to 2 pi to 0 and 2 pi to pi. That gives you 2 pi and 3 pi. Now over here on this side, the angle that gives you that ratio would be pi, and we already have it there. And then when you add pi and 2 pi is 3 pi, we already have it there too. So this equation, or this part of the equation, doesn't add any new answers. By solving for this one, you get all the possible answers. So now we just divide by 2. Each of these divided by 2, and this is what you get. Alright, for 19, I converted the tangent and cotangent to sine and cosine. So here it is. Tangent 2x, notice how both of these are 2x. And then cotangent x, notice how these are both x. Okay? Because I'm adding or subtracting two fractions, I need a common denominator. So the common denominator is this times this, and that's what you see right here. So this fraction needs sine x, so there it is. And this fraction needs cosine 2x, and you see it right there. Okay? So now that I did that, I can write it all as one fraction, and here you have it right here, one fraction. Now you know that if a fraction equals 0, that means the numerator equals 0. Okay, so that means this up here equals 0, and that's what you see on this line right here. Okay, just the numerator. So all I did here, I recognize this as one of the double angle formulas, but it's not written like this. Okay, so what I did was I rearranged the terms. So notice how I put negative cosine first, plus sine second. So I just switched these two terms. Then I factored out a -1, or just a negative here. So I factored out a negative, so there's a parentheses. So when you factor out a negative from here, you get a negative from a positive, you get a negative. So this right here is a cosine 2a formula, this one. Or not 2a, but cosine a plus b. Alright, cosine a plus b. So here's a, here's b. So I took, I rewrote this as cosine a plus b right here. So here's a, here's b. Together they add up to 3x. When I divide by a negative, well, 0 divided by a negative is 0, so that didn't change anything. Now the 3x tells you that you're going to go around 3 times. So you're going to go from 0 to 6 pi. So then you put 3x equals, now the angle associated with this ratio for cosine is pi over 2 and 3 pi over 2. So that's one time around. The next time you add 4 pi to here and 4 pi to here, and that gives you this set of numbers. For the third time around, you add 4 pi here and 4 pi here over 2, and so that gives you 9 pi and 11 pi over 2. Okay? Divide everything by 3, so all these 2's become 6's. So 3 over 6 is pi over 2. And 9 over 6 is 3 pi over 2. So here are the final answers right here. For number 21, they gave you this information, these two. So from here I drew the angle, which they created a right triangle. This tells you that it's in quadrant 4. And so this is y over r. So I'm missing x, and x turns out to be 4. So then I wrote the formula. So sine 2u equals 2 sine u cosine u. You have sine u was given to you, and it's here too, right? And then cosine u is x over r. Remember, this is 2 over 1, so you multiply 2 times negative 3 times 4, that's negative 24. 5 times 5, 25, and that's it. Cosine 2u, I just chose this one. You can use the other two if you want, one of the other two if you want. So here's your cosine u, here's your sine u, you're squaring them, and then you're subtracting. So this is 16 over 25 minus 9 over 25, so that's 7 over 25. Now for tangent 2u, you have two options. You can either put this number over this number, because it's sine 2u over cosine 2u. That's definitely a lot faster. But I wanted to show you with the formula. Okay, but you'll notice that we have the same answer, because if you take this number over this number, this is exactly what you get. Okay, so I just went ahead and did the formula. So here it is. And tangent is negative 3 over 4, so that's what I put here. Then I simplified. 6 over 4 is negative 3 over 2. and then this is 9/16. And I just multiply by 16 over 16, so here 2 goes into 16 8 times, 8 times 3, 24, and then distribute the 16, so that gives you 16 minus 9, which is 7. And if you compare this with what you would have gotten up here, it's exactly the same thing. 23, they give you this and this, so that tells you the angles in quadrant 3. You find your r because you have tangent, you have y over x, so you're missing r, so it's radical 5, Pythagorean theorem. So sine 2u is this. Here are the numbers. Notice I didn't rationalize because I realized that I'm going to multiply those together and it's going to leave me with 5. So I didn't bother with rationalizing. There was really no need. Okay? A negative times a negative is a positive. 2 times 2 is 4, so there's 4/5. Cosine 2u, again, I used that formula. Here are the two values, and again, no need to rationalize right here. So you square this number, and you get 4 over 5 minus 1 over 5. So that's 4 minus 1, which is 3 over 5. Now for tangent 2u, the same thing. I could just take this number over this number and get 4/3, and that's exactly what I got by using the formula right here. 2 times 1/2 is 1, and then 1/2 squared is 1/4, so 1 minus 1/4. That's 3/4. Reciprocal of 3/4, 4/3. Number 25. Okay, I looked at the ratio, and that's what a ratio associated with a special angle. This tells you the quadrant. It's in quadrant 2. I labeled the triangle, and I realized that if I divide everything by 2, I got the ratios on the unit circle, with this being the radius of the unit circle. I divide that by 2, this by 2, this by 2. So then that tells me that u is 2/3 pi. So this angle right here is 2/3 pi. Okay? So when that happens, you have two choices. You can use the formula, or you can do what I did here for number 25. Again, notice I only did it here because I knew the angle, and it was one of the special angles in our unit circle. So I just said, okay, sine 2u is sine of 2 times 2 pi over 3. That's 4 pi over 3. So I evaluated sine of 4 pi over 3 here, cosine of 4 pi over 3 here, and tangent of 4 pi over 3 here. All, special angle. And that's it.